animal so large that it made modern great white sharks look like juveniles, a predator that ruled the oceans for nearly 20 million years, feeding on whales and sharks, shaping marine ecosystems, and disappearing without leaving a body behind. Now imagine that almost everything we thought we knew about this creature was wrong. Its size, its shape, biology, and even the reason it vanished. For over a century, Megalodon has lived in a narrow box inside our imagination. A giant great white, a scaled-up movie monster, a blunt instrument of teeth and rage. Now new research has shattered that image completely. And once you see what Megalodon actually was, the idea of it surviving today stops being exciting and starts becoming deeply uncomfortable. The monster we thought we knew. The classic image is simple. Take a great white shark, triple its size, give it jaws wide enough to swallow two people standing side by side. That image is everywhere. Movies, posters, documentaries, even museum models. This idea did not come from nowhere. In 1835, naturalist Louis Agassiz formally described Megalodon based almost entirely on fossilized teeth. Large, triangular, serrated. They looked similar to great white teeth, just absurdly bigger. From that single resemblance, Megalodon was placed near great whites on the shark family tree. Later reconstructions in the 1990s reinforced the idea. Same body plan, same proportions, just scaled up. That assumption went unchallenged for decades because sharks create a problem for science. They do not fossilize well, their skeletons are cartilage, not bone. Teeth are usually all we get, and Megalodon left behind a lot of teeth. Each individual carried 276 teeth at a time. Over a lifetime, a single animal could shed more than 40,000. Over 19 million years, the seafloor became littered with them. Fossil teeth were everywhere, and so scientists built an entire animal around dental evidence alone. That shortcut turned out to be a mistake. What the teeth hid? Teeth tell you what an animal eats. They do not tell you how it moves, how it distributes mass, or how it scales with size. For years, length estimates placed Megalodon at around 15 to 18 meters. Already massive, already terrifying. Then came a rare discovery, a partial fossilized vertebral column found in Belgium and preserved in Brussels. 11 meters long, and that was only the trunk. No head, no tail. In 2025, an international team led by paleobiologist Kenshu Shimada revisited this specimen with a new approach. Instead of forcing Megalodon into a great white template, they compared it to over 160 living and extinct shark species. They looked at proportions, head length relative to body, tail size relative to trunk, how large animals actually scale in water. The results forced a recalculation. When the missing head and tail were added using realistic shark proportions, that Belgian individual measured roughly 16.5 meters. That aligned with earlier estimates. But then the team looked at a much larger vertebra from Denmark, 23 centimeters across. That vertebra did not belong to a 16-meter animal. Scaled properly, it pointed to individuals exceeding 24 meters in length, nearly the size of a blue whale. Estimated mass approaching 94 tons. That is not a bigger great white. That is an entirely different class of animal. The body everyone got wrong size was only the first correction. Shape was worse. Earlier models assumed Megalodon had a bulky, torpedo-shaped body like a great white. Shimada's team noticed something strange when reviewing older digital reconstructions. The math behind the proportions did not hold up. They rebuilt Megalodon again, using the same comparative database. The conclusion was unsettling. Megalodon was not stocky, it was streamlined, its snout was shorter, its jaw flatter, its pectoral fins longer and more supportive. The body distributed mass more efficiently. In silhouette, it resembled a lemon shark more than a great white. This mattered a lot as a bulky body creates drag. Drag limits size. It is why great whites top out around 7 meters. Anything larger would lose the speed required to hunt. A streamlined body changes everything. This new form explains how Megalodon could grow to such extreme lengths and still move efficiently through the ocean. It also explains why it could range globally. Fossil teeth appear on every continent except Antarctica. This was not an ambush predator. It was a long-distance, energy-efficient hunter built for scale. Born a nightmare. The revelations did not stop with adults. Fossil vertebrae indicate newborn megalodons were already between 3 and 4 meters long, larger than many adult sharks alive today. And like modern great whites, they likely practiced intrauterine cannibalism. Embryos consumed unfertilized eggs and possibly smaller siblings before birth. Survival pressure began before they ever entered the ocean. From the moment they existed, they were apex predators in training. Why something this perfect disappeared? Knowing what Megalodon truly was makes its extinction harder to explain. Climate alone does not solve it. For years, colder oceans were blamed. But global distribution data shows Megalodon tolerated a wide temperature range. Evidence suggests it was likely mesothermic, able to keep its body warmer than surrounding water. Cold alone would not have stopped it. The timeline tells a different story. Megalodon populations peaked around 16 to 12 million years ago. Then they declined. This decline coincided with a massive extinction event among large marine animals. Whales, dolphins, sea turtles. Nearly half of large marine mammals vanished. Food collapsed. At the same time, a new competitor rose. The great white shark, smaller, faster, needing far less energy to survive. When prey became scarce, efficiency mattered more than dominance. Megalodon's greatest strength became its weakness. It needed too much. By 3.5 million years ago, the last Megalodon teeth appeared in the fossil record. After ruling the oceans for nearly 20 million years, it was gone, just like that. So could it still be alive? Eyewitness accounts never stopped, and neither did speculation, even the most hilarious ones. A 1918 report from Australia claimed a shark longer than a football field. Modern headlines still misidentify basking sharks as something impossible. A 2013 documentary blurred fiction and science so effectively that millions believed it. The arguments repeat. The ocean is unexplored. Giant squid went unseen for centuries. What about the Mariana Trench? But Megalodon fails every survival test. A 24-meter apex predator cannot hide. It would need enormous amounts of food. It would leave bite marks, carcasses, genetic traces, changes in modern marine food webs. We see none of that. The deep ocean does not help. Below 8,000 meters, even small fish struggle due to limited energy availability. There is not enough biomass to support something that once fed on whales. Even the famous trench teeth tell a mundane story. Their pale color came from mineral preservation, not recent age. Megalodon teeth are not young, they are simply well kept. The terrifying answer: so is Megalodon still alive? The simple answer is no, but that answer should not be comforting at all. The terrifying truth is that we underestimated it in every meaningful way. It was larger and more efficient, even more globally dominant than anything we imagined. And it disappeared not because it was weak, but because the world changed just enough to favor something smaller. If an animal this optimized could vanish, then extinction is not about power. It is about balance. Megalodon does not need to survive into the present to haunt us. Its real legacy is showing how thin the line is between dominance and disappearance. And the most unsettling part is this: we still have never found a complete body, which is wild. Until then, the largest shark to ever live remains known only by its teeth, its shadows, and the uncomfortable reminder that even the greatest predators are temporary. So there it is. Megalodon is extinct, not hiding, not waiting, not lurking in the deep. But the story does not end with relief. It ends with uncertainty. For nearly 20 million years, the largest predator the oceans have ever known lived, hunted, and vanished, leaving behind nobody and an image we misunderstood for over a century. Until a complete fossil is found, until every assumption is settled, the mystery remains. And that feels strangely fitting.